Okay, we've got this infinite convergent series right here, which if you start writing out some of the terms, you see that it's a geometric series where r equals 1/3, which is less than 1 in absolute value, and the first term is 2/3. That means that the series converges, and you can actually calculate the sum using the formula a over 1 minus r. So this series actually adds up to 1. What we're trying to do is come up with an upper bound for the remainder if you add up like the first 6 terms or the first 5 terms, or in the case of this problem, the first n terms. So we're saying if you add up the first 6 fractions, the remainder left over to get to this final sum of 1 will have this as an upper bound. So the question is, how do we evaluate this where this is an n instead of a 6? So here is a specific example, but here's the general example. The nth remainder, the remainder after we've added up the first n terms, has this as an upper bound. And I can rewrite that by pulling this 2 out front and moving the 3 to the x to the numerator. So I've got 3 to the minus x. So this is the upper bound in terms of n, however many fractions you add together. So how do we evaluate that? We want to replace the infinity symbol with t and let t approach infinity, and then evaluate this integral right here, and finally let t approach infinity. So the part that I've circled in red here, I'm going to use u substitution to arrive at what the antiderivative is. If u equals minus x, du equals minus dx. So that means I put a minus 1 here and a minus sign out front. And then I replace minus x with u. And finally, the antiderivative of 3 to the u is 3 to the u divided by ln of 3. With this minus sign out front. So this is our antiderivative right here, this thing in red. But I want to take the limit as t approaches infinity with this multiplier of 2 out front. And now how do we evaluate this? Well, we put 2 in for x minus we put n in for x. And then let t approach infinity. And the thing to realize is that 3 to the minus t is the same as 3 over t. As t approaches infinity, that's going to approach 0. So this term, as t approaches infinity, disappears. And then we have 2 times minus a minus 3 is plus 3. So it's 2 times 3 to the minus n over ln of 3. That's the upper bound in terms of n. Now if we go to the next board, you can see that I've actually evaluated this on Desmos. Here's the definite integral, and here is what we ended up with. And you can see that, well, the numbers aren't 85046,145. Something happened out there at the end, but this is the upper bound right here. Okay, if you have any questions, post a comment.